It is my great pleasure to introduce Fabrice Gaillard as the 2021 recipient of the Science Innovation Award of the European Association of Geochemistry. Let me first acknowledge the colleagues who contributed to the nomination letter of Fabrice: Rajib Dasgupta, Craig Manning, Max Smith, and Francois Holtz. They did really a clever job for nominating Fabrice for this award. The first time I met Fabrice, it was on the beginning of this century. He was a PhD candidate at ISTO. He was studying iron oxidation in hydrous silicate melt, tackling the mechanism and kinetic of the oxidation process and thermodynamic equilibrium of the melt. It was among the first time that hydrogen and iron were simultaneously considered in the control of the redox of melts. It was already possible at this time to identify the qualities of Fabrice that became later the trademark of all his achievements: inventiveness, quality of the experiments, and use of multidisciplinary approaches. Most of Fabrice's studies combine collection of experimental data, theoretical simulation, and direct application to natural cases. This is really the trademark of Fabrice's works. Fabrice's experimental research has always been characterized by innovation with clever design and execution, but also associated with a strong interest in understanding of the physical microscopic mechanisms which are at the origin of the properties he measures. This approach is extremely powerful. It gives high confidence in the extrapolation to natural conditions. During his young career, Fabrice has developed a strong international recognition for his experiments on oxidation and conductivity. He is currently one of the referents in Europe on the conductivity measurement in melts, and he is frequently asked as a reviewer for papers in the field. A major trend of Fabrice's personality is his strong capacity to think in terms of global perspectives. His design of experiments provides solutions to a wide range of important geochemical issues. It includes various reservoirs of terrestrial planets, mantle, crust, and atmosphere. Fabrice put high priority to understand the microscopic origin of the mechanisms and to carefully model them, but he never forgot the big figure. He is able to carefully assess impact at regional or planetary scale. I mean, taking care of the problem of scale change and of the possible averaging effect linked to the change of scale. I would like to list some of his pioneering contributions to the discipline to illustrate the wide range of questions he tackled. Modeling of transport and degazing of sulfur species in melt from Earth and Mars. Development of a new model for the melting and the formation of granite in Tibet. Recognition of the fundamental role of carbonatite melts in the conductivity and seismic anomaly in the Earth's mantle. Identification of the role of assimilation of organic matter and sediment in the production of Siberian traps. The variety of questions addressed by Fabrice in the last 10 years is impressive. Fabrice addressed subjects such as atmosphere of exoplanet, planetary habitability, Earth accretion, early Earth atmosphere, growth of continental crust, origin of kimberlite, redox state of magma, carbon cycle, melt viscosity or deposit, magma crust interaction. I stop here. The list is already astonishing. There is another dimension of Fabrice's character that should be mentioned here. His natural ability for kind and efficient leadership and mentoring. He has accreted around him many young, bright scientists and has largely supported them to reach independency and recognition. It says a lot on his qualities of leader. Finally, from what I told you, you can already identify in Fabrice Gaillard the direct affiliation with the approach followed by Ringwood. To my knowledge, this is the first award received by Fabrice, and I am delighted that this first one is the Science Innovation Award of EAG, which is associated with the name of Ringwood. It fits so well to you, Fabrice. Congratulations.